Okay, welcome back to scientific computation using Python. In this video, I want to show you a simulation of gravitational attraction between masses. So the problem that we are going to discuss is this one. The gravitational force between two masses, m1 and m2, is given by the formula g m1 m2 over the distance squared. This is the magnitude of the force. The same force applies to the first mass and the second mass. The directions are opposite. Forces are equal and directions are opposite. So M1, M2. For example, in this notation, the force on M2 is defined as force on 2 due to mass 1. So therefore, this is a vector representation, and the force should be taken as a vector. So F21 is the force on mass 2 due to 1. Likewise, F12 is the force on M1 due to M2. So we can say that the vector F21 is equal to minus F12. Okay, let's now go back to our Python and write some code to simulate this, simulate the physics of two gravitational bodies. Okay, first start by importing NumPy and matplotlib. Okay, now in order to do this simulation, we need some constants. Obviously, the masses, let's do M1 and M2, 1 and 2. As I described in detail in the lecture, I am using not metric units here, but some arbitrary units in which the masses are given as 1 and 2 to make the computation easier. We can talk about how to set the scales later. Now, having two masses, what about the distance between them? In order to calculate the distance, we need to locate these masses on an xy coordinate. I forgot to say that at the moment we will be doing these calculations in 2 dimensions, 2D. So extending them to 3D should be obvious, but this is not to say that it is going to be trivial. However, once you understand the 2D problem and code it in 2D, it will be much easier to transport your code into 3D. Okay, now for the positions, let us say position of first mass x1 and y1 is, I always like to do this with random numbers so that my code is general. Therefore, it should be I should be able to debug my code and see if I am doing things right. So that if my code runs in the general case, then it should therefore it will run for any point. But if I do it for specific points, maybe I will miss something, and then that can appear when I run the code in general. So this is my first point, and this is going to my second one. Okay, let us run this program as is and then see the results. Okay, let us see if P1 is in memory. Yes, this is P1 and that is P2. Okay, and this is X1 and that is Y2, for example. Good. So my points are between 0 and 1 here. Let us, before doing anything, let's plot this on a graph so we can see where the points lie. I always begin by the PLT subplots without an argument, without a parameter here. This gives a figure and one axis. Okay, so now I'm ready to plot my points x1, y1. Let us do it with a dot, with a larger dot. So here are my 2 points. I want to run it as this simply to see what I get. Okay, good. I have 2 points. Colors are different. Okay, but they're on the corners of this rectangle, which is somewhat arbitrary because I didn't specify the x and y limits. So before I do that, before doing anything else, let me set the x's right. So I want to do it this way. First, I want to set the x limit, make it from 0 to 1, and y limit from 0 to 1, and then the aspect equals 1. Okay, this is going to set the limits and set the aspect to 1. Let us see the same again. Okay, nice. Now I have my x's, beautiful, later on with the same aspect ratio, and the limits I can see from 0 to 1. This is good. I can also make the figure size a little larger by supplying a figure size here. Figure size. A 7 by 7 I experimented earlier and find it easy. Find it quite nice. So let me run that. Okay, so these are my 2 points. The colors are set in somewhat an arbitrary way. Therefore, let us make the first one blue and the second one red. Blue and red. Let's run it again. Of course, now when I run it again, I see different random numbers. As we discussed in the class, let us see the random number generator with, for example, 1, so that we always get the same. Okay, now one of these points are away from, is really near 0.0. I think it's better if I do something like this, extend limits so that even they are near the boundaries, I can see them clearly. Okay, this is good. Now I can I have a dead space on my corners, but at least I can see my points clearly. Good. And also, how about we see the size of the masses in this plot? I can do that this way: marker size proportional to the masses. Okay, marker size mass 2. So the second plot is proportional to M2 and the first one is proportional to M1. Let us run this again. Now I see extremely small 2 dots, so instead of changing the masses over there, I would like them to be 1 and 2. I want to make this larger by multiplying by 10. Okay, now I have my 2 masses proportional to their size. I can see them clearly. Good. Okay, now we can see our 2 masses. Now we come to the point where we calculate the distance between these 2 points. Of course, the radius, the distance between these 2 points, let's call it D, is the Pythagorean distance plus y1 minus y2 squared, and then the square root of this. Okay, so let me run this. Okay, so I need another parenthesis here. Okay, let us see it on the, so it's not R but D. Okay, that's the distance, and it should say 0.6. That is reasonable, from 0.2 to 0.8. Good. So I can calculate the distance. Let's clear the screen a little there. Okay. Now of course I need the vector between these 2 points. So in class I have done this differently, but here I would like to do this with a function here. So I want to define a function, and that will be unit vector. This is going to be a function that will give me unit vectors between P1 and P2. This is going to be the unit vector pointing from point 1 to point 2. So I begin by unpacking the points. Okay. Why do I work with P1 and P2? Because the function definition will be a little bit cumbersome, but when I use it in my program, it will be much concise. So let me use this code here. That's the distance between these 2 points. Correct this a bit here. Okay. And then 2 vectors x2 minus x1 and vy, y2 minus y1. Okay, so these are the vectors pointing from 1 to 2. Now if I divide these 2 vectors by d, I will get the unit vectors, which I call ux and uy. So okay, now if I return ux, uy, this function is basically giving me a unit vector pointing from the first point to the second one. Okay, so let us test this. First, let's test the unit vector. For example, ux, uy is going to be the unit vector from my point 1 to point 2. They are defined over there here. Uy. Okay, good. So I am now given 2 unit vectors. The best way to see if they are calculated correctly is, of course, to try it with a with a curve plot. I want to plot at x1, x2, ux and uy. Okay, and then let us do the regular scaling and scale units xy. So let's see if this will correctly draw the unit vector I calculate here at point x1, x2. Okay, of course this is not supposed to be x2 but y1. Good. So my first point, and this is the unit vector pointing towards the second mass. How about, can I use the same for the second mass? Let us see, do that. So ux, uy this time should be between P1 and P2 and P1. And then I will be plotting that on the second one. Okay, let's run this and see. Okay, this is very good. So I have now the unit vector pointing from the second mass towards the first one. But because the opacity of the points, because of the opacity, you can't see the full vector. So I want to add an alpha to both of them, make them transparent. I want to make the points transparent and the dots transparent, so we can see clearly the two unit vectors. And then if I switch this off for a while to see if, okay, now I want you to pay attention to two facts. The directions of the vectors are correct, and also they are unit vectors. They are always the same, no matter which 2 points are selected. Good. Now I have two unit vectors. Let's turn this off. I have two unit vectors. Now I can calculate the force, and I want to do it here. Force is G times m1 times m2 over the distance between them squared. Okay. Now G is not defined, so let me put it here. And for the same reasoning that I am using 1 and 2 units for unitless masses, I want to set G as 1.0. Therefore, I am using some arbitrary units. Okay, I need the distance still, and I can always write another function to make it clear. So I want to write a function to get the distance between scalar distance between 2 points. Def, so this is going to be distance between point 1 and point 2, and this should return nothing but, okay, I think I should have this here. So getting the points, calculating the distance, and returning it. Okay, when I have this function, I can, instead of writing it over there, I can get the distance using this function p1, p2. Convince yourself that the order of these functions are not important. Distance is using unit vector function is using the distance function, but after compiled, it will be available to the whole program, so I can write it this way. Okay, so this way, if I get the distance between P1 and P2, my distance is calculated, and that should be my force. So let's run this. Okay, everything looks all right. So this is the distance between my points, and this is the force between my points. Good, I've calculated the force between 2 points. I want to plot this force to see that I can actually plot it on the, I can plot it correctly on the graph. So I want to do it this way, cube plot. at x1 and okay, I can plot this on the plot, on the graphic plot, x1, x2. If I do it f ux f times uy, this will exactly do what I am intending to do. So let's do the scales here again. And the alpha, I want to do alpha more pronounced. So I want to do this on the first one. So here is the first point. So the unit vectors from the first to the second one. Therefore, I want to plot it. Again, this is supposed to be y1. So at the first point, I calculate the force. Let us do this here. I calculate the force and then plot the force vector. Again, this is the projection of the force vector over the ux and uy unit vectors that we spend so much time when we discuss the unit vectors. Let us see how this works. Okay, so this is the force vector. Maybe I need to scale this a little to make it a little smaller. Let's see if this works. Oh, I should be going the other way. Okay, so that's the force vector. Maybe this is even better. Okay, so unit vectors, and this is the force vector. Let us turn the seeding off to see how it works. So when they are closer, the force vector is larger, even larger, quite large. Now the distance is a little separated, so they are okay, smaller and even smaller. So it looks like it is working properly. So I would like to do this in a function. So okay, here I can do a function like this. Define force between P1 and P2. Of course, then you need two meshes as well, M1 and M2. What is the force between M1 and M2 at points P1 and P2? Therefore, I need the distance. Distance is distance P1, P2, and then the force is G is available to all the functions over D squared. And then I can return the force. Okay, so this gives the force between two masses. So therefore I don't need the distance anymore, and I can say F is the force between M1, M2, P1, P2. So that gives me the force, and then the unit vectors. So in this way I can get the force magnitude, and the unit vectors are calculated separately. If I want that, I can also calculate them within the function. I want to show you that one also. So unit vector x and unit vector y are unit vector from P1 to P2, and then I can return ux and uy as well in my force function. Therefore, so I don't need now this line anymore, but ux and uy, I can get them directly from my force function. So this returns the force and the unit vectors. So within this, therefore I am getting actually a vectorial vector representation of the force when I get the unit vectors also. But again, let us remind us when we read this in the future that this is actually calculates the force vector between two masses m1, m2 at p1, p2 locations, and calculates the force vector and the unit vectors pointing from m1 towards m2 and calculates, okay, and returns the force and the unit vectors. So this explanation will help me when I have a look at this function after revine. Okay, so therefore I calculate the force here and plot the force. Okay, let's run this. Good. Actually, I have made my program quite concise. So basically, this part, if I don't use this part, here is the whole code. So take this part away. Okay, I commented out. Now actually my whole code is a couple of lines long. Here I put my variables, I get my points, set the figure, and then calculate the force and unit vectors, and then plot them. So let's run this again. Okay, of course, I took this out, so I can't see the points. Maybe it's a good idea to have them over there. After setting the coordinates, I can my two. Okay, so this is the force from the first one to the second mass.